It is the best part of our course because we want to make an auto movement system for the UGV in our simulator. Okay, in this step, we want to make a UGV or unmanned vehicle, ground vehicle, and with the auto movement system, not manual movement. It seems it has auto driver, and it can find his destination and go there and go to the another destination for that. Okay, let's go to the another scene. For doing that, I create another scene here and I save it inside of scenes folder. I say level 2 auto movement. Okay, right. Now in this scene, initially we add a train. Okay, and like before, we need to write some mountains, something like this, but increase the opacity. Oh no. Oh my god. Okay. It seems is good. Now let's do smooth it and do it very fast. Okay. Our mountain must be smooth for better movement with our UGV. Alright, now add some textures. I'm doing these tasks very fast for saving our time. Create layer, we say ground. Oh my god. This part is okay, perfect. Okay. Initially, we need to make our train movable by AI. For doing that, we have to go to the window and AI, artificial intelligence, and go to the navigation. In the navigation tab in here, you can see some options for make your train walkable by AI. But I don't want to talk about the details of it. Let this as a default and click on bake. Right now it's processing our train and related on the angles of the mountain body and hose and other heights in our scene and make our train walkable, and we will see the result as a blue layer above of our train. Okay, as you can see, these parts is not walkable by our train by our AI, or for example somewhere else I can find. Oh no, it's perfect. Okay, it's good, and you don't need to have any concern about, because once you click on inspector, it's not visible in your game tab. It's only visible once you click on navigation. Okay, after doing that, we press Ctrl S for saving, and we want to add our UGV to our scene. is our beautiful UGV. It has already the camera, we don't need it. Okay, we need to decrease the size. It is too big. Okay, now it's better. All right. Important thing is we need to add a component. It's called inside of the navigation. It's called NavMesh agent. It is the walkable mechanism for movement our character. As you can see, this green invisible cylinder is our NavMesh agent mechanism, and as you can see, the bottom of this cylinder in here. So once we play our game and our scene, our UGV will be here, the position of the bottom of the cylinder. So it is not good. For fixing that, we need to change the size of it. In here we can increase and the radius in here. Yes, we can put it in here. Then we can put the object a little bit higher. Okay. Now, no, it must be a little bit higher. Perfect. It's perfect. Okay. In the NavMesh agent, we can control any parameters about the movement. For example, the speed, the angular speed, acceleration, auto braking, stop distance, or other things. But it is the string and the movement variables. For fixing the for have auto movement with the NavMesh agent, we need to have a target and destination in our scene. So we will add it. We'll call it target. It is an empty object. Once we put it in anywhere and give this and transform position of this target to the NavMesh agent, the UGV will go to this destination automatically. So because we want to see the target, we need to add this arrow as a child of this target. Oh, it's too big. It has camera as well. We don't need to have camera for it. Okay. And we need to put it something like this. All right. It makes sense. So it is our target. Here is our target, not here. Not the point of arrow. The target's position is here. So the UGV will come here. Okay, now we have our targets in the scene and our robot or our UGV has a NavMesh agent. I don't want to change the parameters in here. We will change them inside of our script. Okay, for the movement management of our UGV, we need to have a script. Inside of the scripts folder, we create a C# script. It's called auto movement. Okay. All right. It is our C# script, auto movement, and public class auto movement in here. Initially, because we want to use a component of NavMesh agent, we need to define the library of it. And this library's name is one of the sub-libraries of Unity Engine. So we can using Unity Engine dot AI. Okay, now we can call the NavMesh agent. Here we say public NavMesh agent. We call it NavMesh agent. Okay. And another one is public directly transform target. Perfect. In here, only thing is we say NavMesh agent dot destination equal target dot position. We say the destination of our NavMesh system is the position of our target. Okay, let's come back to the Unity editor and test it. Attach this auto movement script to the UGB and drag and drop the NavMesh agent component to the NavMesh agent variable, and also the target, not the arrow, the target inside of the target. Oh, sorry. Perfect. Now I want to put my camera in this angle to better see the result. Oh, the angle of the NavMesh agent is wrong. But it works. Okay, and now let's see why the angle of it is wrong. Because it tried to look at to the destination with the angle Z. So it will be like this. As you can see, the UGB's angle as a default is 90 degrees and it is wrong. Remember, the angle of your object once you want to use NavMesh agent must be 0, something like this. After that, you can rotate your mesh manually. First, I need to put it in here, then rotate it. Oh, maybe we can add an empty object. Put something like this. Yeah, it's better to add an empty object to our scene. Now we say UGV body. Okay, and we put it in here. Then we select all of them and duplicate and put it as a UGV body. Then take all the UGV's main objects, the hide, then you can rotate your object perfectly. But no, it's better to put them here and set the UGV body in the 0, 0, 0. After that, select them and put as the children of UGV body and rotate it. Perfect. We don't have any restrictions in the Unity. We can do anything we want. Okay. And also, as you can see, the Z angle of our NavMesh agent is this side. So our front of our UGV is this side. So we need to rotate our UGV as well. Something like this. Okay, then put it in here. Okay, let's test it again. We did a lot, but it works well. I love it. It's so beautiful. Okay, we arrived to the destination, but our script is not optimized at all because the function of NavMesh agent destination always working and 20 or 30 times per frame. So we need to control that with the new situation. We say once we are in the destination, this function doesn't need to work. So we say public boolean say arrive equal false. So we say if and once the arrive equal false, it's try to put the destination as a target with target's position. Once we arrive to the destination, we don't need to have it, and this process can be stopped. But how we can understand we arrive to the destination? For doing that, we have two solutions. First, we can select a trigger and put a trigger of the target. We will discuss more about the triggers in the future, but we can, as a titles, we can say we can put a trigger as a for target, and we say when hit the UGV, try to stop it. But another solution is we can make it self-sufficient by the UGV management controller by comparing the current distance between UGV and target destination. Then we can define a range for the movement system process. For example, we say, okay, once we arrive to the 5 meters of the destination, stop the working, or 5 meters, 1 meter, 1 millimeter. It doesn't matter. It depends on our decision. Okay, first we need to define a public float, and it's called distance. We call it dist, and also we call public float range. As a default, we can call 5 meters. I don't know, or 3.5 f. Excuse me. Remember, once you want to define a float number inside of your script, after your number after point, you need to write the f. Without f, you will have a problem. So write the f, not the capital F, short f. Okay. How we can understand the current distance between the position of UGV and the destination in any time. We say distance will be equal with, it is the formula of the distance in Unity. Vector 3, it means we need to compare the distance between x, y, z. Dot distance. In the parentheses, we need to call, as you can see, vector 3a and vector 3b. It means we need to write two positions in here, the position object A and position object B. Then this function try to give us the distance between two positions. The position object A will be our UGV's position. So we say transform dot position, and we need to add comma, and it's time to add the position of our destination, so the target position. Okay, in here we will see the distance number, so we need to check it. If destination is less than range, for example, we call the range 3.5. If the destination is 3.4, so the arrive needs to be true. So this function will not work. But once we are out of the range, so the destination is more than range. For example, the range is 3.5, destination is 10. The arrive will be false. Okay, and also for to be sure our UGV will be stop at the position, we need to call another function, another solution for it. Public float speed movement. Okay. For example, as a default, speed movement will be, I don't know, 8. Okay. In the start, void start, it means in the first moment of scene launch, the NavMesh agent speed in here, oh, that's the compiler, works. Okay, in the NavMesh agent speed, we have 3.5. We need to change it. We can't change it. NavMesh agent dot speed will be equal to speed movement. Okay, then we can use this function and this solution to stop our UGV once it arrives to the destination. With this solution, NavMesh agent dot speed will be equal 0 once it arrives to the destination, and once it is out of the range, and it's not arrived to the destination, NavMesh agent speed will be equal with speed movement. That's it. Now let's come back to the scene. Okay, in here, destination is 0, range is 3.5, and speed movement is 8. Okay, let's test it. The destination is 28, 80, 50, and okay, it has been stopped. The speed is 0. Look at this. the destination of the UGV is equal to destination of target, and now it is optimized than before because our CPU is not busy for the NavMesh agent destination. Okay, and also we can change the destination of target, and it works dynamically. Perfect. It is so beautiful. All right. It works well once we have one target. Now I want to add more targets to our scene. For example, we say target 0 in here, but target 1 will be here. Oh, sorry. And target 2 will be here. Now we have 3 targets. Now we have 3 targets in our scene. It means the UGV must go to the target 1, target 2, and target 3. So we need to say once arrived to the destination, the target position needs to be changed. For doing that, we have 2 solutions. The first solution is we can say the target position. We need the target of our auto movement system and go to these positions, but not by our UGV management movement itself. So it moves something like this, and our UGV follows it. Another solution is we can define several targets for auto movement system. So we need to have list an array of our target. For doing that, we need to change our variable from a single object to array of targets. In here, as you can see, our mechanism has been changed. In here, we need to say public int counter. Let's come back to the scene, and sorry, we need to change something in here. So we say counter, and in here, let's come back to the editor. I will explain what is the difference between the current situation and the list of targets. In here, the target is list of objects, not only one. We can add many transform to it, not only 3, maybe 300. So we can drag and drop our targets to this array. Target 1, target 0, target 1, and target 2. As you can see, element 0, element 1, element 2. We can define several of it, but we don't need it. So click on the target 3 and remove it. Perfect. So the counter will be decide which target is our target destination. For example, if the counter equal 0, it's try to goes to target element 0. If the counter is 1, the target will be the target 1. The counter 2, the target 2. So once we arrive to each destination, the counter needs to be plus plus. For example, in here, only thing is the counter, once we arrive to the destination, will be plus plus. But not a simple method, something like this, because once we arrive to the target 3, it's try to increase it, and the counter will be 3. But because we don't have element 3 in here, we have only element 0, 1, and 2. Once we arrive to the element 2, let's try to increase it, and the counter will be equal 3. Because we don't have element 3 in here, our mechanism will have a problem. So initially we fix this problem and we will not face with the bug. We say if the counter is not equal amount of the targets, all the ingredients of targets. This mechanism is target dot length. But for better understanding of it, we can have an instance for it. For example, the counter will be 1. As a default mode, it is 0. Okay. Now go to the 1 and go to the 2. And it is still the target length is 3. Okay, in the first moment it is 0, so the counter is not equal 3. 0 is not equal 3, and so it's plus plus. In the next time the counter is 1 and it is not equal 3. It's plus plus. And the next one, the counter is 2 and 2 is not equal 3 and it's plus plus. It still has a problem. So we need to say the counter will not be equal with the last ingredients elements. So we can call this one with target.length minus 1. So we will say try to plus plus the counter once you are less than the target length. Once it is 0, it's try to plus plus. Once it is 1, it's try to plus plus. Once it is equal to, don't need to plus plus, and it will be end of our destination. Okay, come back to this editor and we will see a new parameter. It's called counter. Okay, now let's test our dear UGB. Okay, dear. Oh, beautiful. Look at this. The counter is equal 1. It goes to the destination 2. Beautiful. Perfect. It's arrived. It's arrived to the destination and change the target position here and it follows. We can use this mechanism to create auto movement system in our simulator, and we can simulate any situation of our robots inside of our simulator. Okay, let's go